When we start thinking about charge, we start by thinking about a few simple experiments. Now, I expect that you already know something about charge, but it's really important to understand what is first observable and the physical basis on which we are actually talking about electrostatics and charge. So the first thing we're just going to be looking at is how some simple objects attract or repel each other, or do nothing, just sit there and don't interact at all. The things we're going to be looking at in particular is rubbing plastic with wool and rubbing glass with silk. So we'll be talking about plastic and glass typically that has been rubbed with these two different materials. And then after our first batch of experiments, we're going to look at some second set of experiments, including looking at other objects and other materials such as metal. So the first experiment is really simple, but very important. If we have two objects that have not been rubbed, meaning this is plastic that hasn't been rubbed with wool, it's just been sitting there, we hang one from a thread. So this is just hanging. We know that the forces acting on it are tension from the string and gravity downwards. We then bring in the second rod, literally holding it in our hand, and we bring it near that rod. These two rods, nothing seems to happen. They don't seem to attract, they don't seem to repel. How do we know? This rod, the hanging rod, continues hanging straight down. So two rods that have not been rubbed seem to exert no forces on one another. But now, this is where it's interesting. We have two rods that are both plastic and that have both been rubbed with wool. Now, initially this rod was hanging straight down. So we would imagine that it's hanging straight down if this rod was not actually there. In that case, the only forces acting on it would be tension up and gravity down. As we bring this rod in, we see that this one, the hanging one, swings to the side. Now, it's a little bit hard to tell from this picture, but you can imagine that it would actually stay in this position. It's not actively swinging back and forth. So if it's hanging in this position, we know that gravity's pulling it down, tension is pulling up to the side, so there must be a third force for it to be in equilibrium. This new force must be pulling it to the side to cancel the other component, the sideways component of this tension force, and it presumably has something to do with the fact that they have both been rubbed. And again, that previous experiment showed that this doesn't happen if they haven't been rubbed. So that's why we care about that previous experiment. So something's going on here, and this is seemingly a new type of force that we need to investigate. The next experiment we can do uses two different materials. In this case, the glass has been rubbed with silk, the plastic still rubbed with wool, and again, initially, without bringing the glass in, this plastic rod would have been hanging straight down. We bring in the glass rod, and we then see that the plastic rod swings towards the glass rod, again implying a sideways force, a horizontal force, that is attractive towards the glass. So this is interesting since, again, this now has a new force, but before, when we had two plastic rods, we saw that it was pushing away, and now with plastic and glass, it's attractive. So this tells us something more. And the last thing we can do is actually think about some different strengths. So as we increase the distance, we see that it swings out not as far. If you actually bring this in closer, this would swing out farther. The other thing you could do is redo the experiment by rubbing them more with wool, and then you would see this swing further for the same distance. So increased distance corresponds to more rubbing or bringing this one in closer. So that starts to get us towards something quantitative. So there's a few really important takeaways here. And again, we haven't talked about anything specific about charge yet. We're simply trying to analyze some experiments. The first is that the force is long range. We're not actually touching these objects, that they're interacting without being in contact. This is quite different than most of the forces we talked about in the first half of introductory physics, though gravity is another force that can exist without two objects actually being in contact. So it isn't our first long-range force, but the fact that it is long range is important, and we know that it isn't just gravity, since this doesn't happen if these haven't been rubbed. So we know that this force is specifically related to the objects being rubbed by a specific material, wool for plastic and silk for glass, and we're going to call this charged. That if they haven't been rubbed, we're going to call it neutral or uncharged, and that after you rub them, they now have a property that we will call charged. And again, we're going to eventually get to the charges that you're familiar with, but we're not there yet. Now, the final takeaway is that this can be attractive or repulsive. Attractive in the case of plastic and glass, repulsive in the case of plastic and plastic. Now, there's a third experiment that I haven't explicitly shown here, which is glass and glass. And this would actually be important to do because you might come to the conclusion that anytime it involves glass, it's attractive, and if it's only plastic, it's repulsive, but that's not the case. Both of these rods could be replaced with glass, and it again would be a repulsive force. So that's another experiment I haven't shown explicitly, but is important. So from here, we're starting to see some patterns, but there's a few more details we must look at before we can really define our charge model.